All right, hey there. Somebody asked about this question 563, part B. They wanted to know how to get the starting value, or not really the starting value, how to get term zero. Okay, term zero. So you might remember from today's class that there are really two things that you need to find to get an arithmetic sequence. It's equation. Okay, it's equation here. You need to get term number zero, right? The hypothetical term zero, right? Whatever the because that's the y-intercept, right? Your sequence graphs, right? If you graphed them out the past few days, they start at one, right? Term number one, term number two, term number three. You have those discrete points, wherever. So, anyways, you need to get the y-intercept, right? Because y-intercept's pretty important for coming up with equations. You also need to get the common difference, right? The common difference too, because the common difference is kind of like slope. Okay, so anyways, arithmetic sequences, they're arranged in a line, right? They're arranged in a line. They're just like the lines you were graphing first semester. So you know that the equation of a line is y equals mx plus b, right? The two things you really need to find a good equation of a line is m, the slope, and b, the y-intercept, okay? So for sequence, it's just a little bit different because sequences use n, the term number, okay, as your input, and then that gets multiplied by the common difference, right? Remember the term number, you have that many common differences of it, and then you add the starting number, right? Y-intercept, whatever you have there, the term number zero together, and that should tell you what the term value is. Okay, the term value is here. Okay, so anyways, this is as far as I imagine this person has gotten who asked me this question here, is that they figured out what the common difference is, and this is, if I'm going backwards here, but if my term number changed by 30 or went down by 30, what happened to the term value, right? The term value. Well, the term value increased by 90 here, right? Increased by 90 here. So that means that each time that the term number goes down by one, it would go up by three, right? It would go up by three. Or if my term number, if I think about going the other way, my term number increased by one, it would be the term value, the term itself would be going down by three. Anyways, common difference here is -3. I'm hoping you got this far, you understand this, that the output of this particular sequence, so the term itself equals -3, the common difference times by the term number, right? How many times you have that common difference, plus whatever that term zero is here. Okay, so anyways, you're watching this video because you're not sure how to get that term zero. I'm gonna kind of go through it with you. First of all, let's look at it. This doesn't work here without a term zero, because if I looked at the numbers that I have here, term number 100, for instance, should have an output of 10, right? Remember, n is the input, term number. T of n, that's, for whatever term number 100, right? I got all those comma separate values. Term number 100, I see a 10 there as my answer, right? As my answer. So if I wanted to use this as an equation here, I would have to do -3 times by 100, the term number, the input, okay? And that would be -300, right? -3 times 100, that's -300. But my output here is definitely not -300. It's 10, right? It's 10, okay? So whatever my term zero is here, that's got to change this. So -3 times 100 is -300. This term zero has got to somehow get us to 10, from -300 to 10. So that's a little bit of a hint on how to do this. Here is how usually this gets taught, okay? It gets taught earlier on here. And then when we did linear functions in chapter 2, this was the method I told you how to do it here, okay? Well, I'm just talking about these points, right? I'm talking about these points. So these points are the things that are going to get me to figuring out what t of 0 has to be. Here, watch this real quick. What do I know about 100? Well, 100 is one of my term numbers. Term number 100. Oh, I got term number 100 right there. Remember, this is term number. Okay? I have this. This represents the common difference. I already know that. That's why 3 is already in there. Okay, what is this here? What is this one again here? Oh, that's the term itself. Okay, this is the term itself. So I want to use an equation because I want to be able to tell for a given term number what's my term. Okay, but the problem is I put that 100 in. I get -300 here. Well, that doesn't give me -3. -300 isn't a term, it's 10. So basically, my point is this here, is you know what one of the term numbers is. Yeah, 100. You know what one of the terms is that goes with it. You have 10. Okay, and you also know the common difference. You figured out the common difference. You followed that in class. Okay, so what you need to do is simply substitute what you know. Okay, substitute what you know. So for the term number, I'm going to replace that with 100. I already know my common difference is -3. I did that work over here, right? I kind of found the slope. Remember, common difference is just like kind of like the slope for an arithmetic sequence. Arithmetic sequence is just like a line, right? It has a slope, and we call it common difference. Okay, and then I need to whatever my equation is doing, it needs to return a 10 for me, or else the equation just isn't working right. Okay, and now I need to figure out what term zero is. So look at this here. I got one unknown left. And that's good. When I have one unknown left, I can solve this equation. So basically, I'm plugging in some things I know. 100 goes with 10. Common difference here is -3. And there's one thing I don't know about how my equation's arranged, and that is what my term zero is here. And term zero is going to be in that equation because you need that starting number to make it all match up correctly, okay? So what can I do now? I can solve this just like I've solved equations normally for a normal variable. We can treat t of 0 kind of as just like its own variable, its own thing. We didn't determine what it is here, okay? So I got here 10, and that equals -300, okay, plus t of 0. I'm going to change colors because that t kind of looks like a plus sign, but no, it means little function notation for the term zero's output, okay? Now I'm going to add 300 to both sides to isolate what I'm looking for, which you asked me about, which was what t of 0 is, okay? And I get 310 for t of 0, okay? So there is my starting value, or there is my hypothetical y-intercept. I have my common difference right there. This works just like y equals mx plus b, where if I have my y-intercept, I can pop it in right here. If I have my slope, I can pop it in right here. I'd get my equation of a line. But the thing is this a line, a connected line? No, it's not. It's a sequence. It's a sequence here. So we use this t of n, term value, term number, right? There's a number there, a number is the input, and t of n is the output, the term itself, okay? So the term itself is going to be dictated. It could be determined by taking the common difference of -3, telling this function machine how many term numbers there are in the sequence we're looking for, and then simply we would just have to add or subtract? No, add 310 to that, and that would deliver us our answer, okay? How can we tell that our answer is right? Well, simply we can check the other point right here and see if we did this correctly. Let's see, shall we? So t of n, our output here would have to, verify this is correct. My output here would be 100 when my input here is 70. So let's marry this with the rest of the equation, and we'll show that 100, well, that equals -210 plus 310. It does. Look, -210 plus 310, that's 100, okay? So I feel pretty confident that my equation is correct, okay? Hopefully you saw how you got t of 0 there. Well, you just simply knew what one of the term numbers was. You knew what that term value was as well, and you knew the common difference. Those are the other three things in the equation for an arithmetic sequence. Remember, the equation for an arithmetic sequence, we'll go over this tomorrow as well too, is that the output value of that arithmetic sequence equals the common difference, right? Not the slope, the common difference, times by whatever term number you're looking for, and then adding that initial value to it, right? T of 0 here. Okay, Master, if you have any questions, thank you for asking. Bye-bye.